Click the bell icon to get latest videos from Ekeeda.
Hello friends, in this video we are going to see one more problem which is based on property number 3 of definite integral. Let us start with problem number 2. Integral 0 to pi by 2 log of cos x dx. In the previous video, we have seen how to find the integration of log of sin x. Now in this case, we need to find integration of log of cos x. For that, we are going to use property number 3, which says integral 0 to 2a f of x dx is equal to integral 0 to a f of x dx plus integral 0 to a f of 2a minus x dx. So in this case, the given integral, its upper limit will be 2a. Therefore, 2a is equal to pi by 2. Therefore, a will be equal to pi by 4. Once our a is ready, we need to find f of x and f of 2a minus x. F of x is log of cos x and f of 2a minus x, meaning we are going to put x as 2a minus x and the value of 2a is pi by 2. So if I put x as pi by 2 minus x, this will give you cos of pi by 2 minus x, that will give you sin x. Now let us substitute the value of a, f of x and f of 2a minus x in this property. Therefore, integral 0 to 2a, we have integral 0 to pi by 2. Log of cos x dx will be integral 0 to a is pi by 4. F of x dx, f of x is log of cos x plus integral 0 to a pi by 4 f of 2a minus x, so it is log of sin x. Now let us consider this as integral I and start solving the right hand side. Therefore, I is equal to, on adding these two integrals, we will get log of cos x plus log of sin x. Here you can use the property log a plus log b, that will give you log ab. For product of sin and cos, we need to multiply it by 2 and balance it by dividing by 2 again. So 2 sin x cos x will give you sin 2x. So we have integral 0 to pi by 4 log of sin 2x upon 2 dx. Now we can go for the formula log of a by b, that will give you log a minus log b. Here we have log of sin 2x minus log 2 dx. After that, we can separate the integrals. We have I is equal to integral 0 to pi by 4 log of sin 2x dx minus integral 0 to pi by 4 log 2 dx. After taking log 2 constant outside, we have integral dx left, whose integration is x within limits 0 to pi by 4. And after solving x, we will get pi by 4 minus 0, that is pi by 4. Now let us consider this as equation number 1. Now let us consider integral 0 to pi by 4 log of sin 2x dx as I1. Here you can put 2x as t. Therefore, x will be t by 2 and on differentiating, the value of dx will be dt by 2. At the same time, we will change the limits. If we put x as 0, the value of t will be 0 only. But if we put x as pi by 4, the value of t will be 2 into pi by 4, that is pi by 2. So I1 will be integral 0 to pi by 2 log of sine 2x is t and dx will become dt by 2. Now we can take this 1 upon 2 constant outside the integral. After that, the similar function can be written in terms of x. As we have property, integral a to b f of x dx can be written as integral a to b f of t dt. In the previous video, we have seen 0 to pi by 2 log of sin x. We have directly considered it as I. So let us substitute the value of I1 in equation number 1. Our equation number 1 was I is equal to I1 is half I minus pi by 4 log 2. Taking half I on the left hand side, this will give you I minus I upon 2 as minus pi by 4 log 2. I minus I by 2 will give you I by 2 is equal to minus pi by 4 log 2. 2 will be cancelled, 2 ones are and 2 twos are, and therefore I will be minus pi by 2 log 2. This is our final answer. I hope friends you have understood this problem. Thank you for watching this video. Stay tuned with Ekeeda and subscribe to Ekeeda.